Hey everybody, it's Mr. Carr again. Today we're going to be starting with 10-2 day one. We're going to start off a deeper dive into our arithmetic sequences and a little bit more about how to model them. Remember, the key about today is that arithmetic sequences follow a linear pattern. So we have an equation that can tell us any term of the sequence based on a couple pieces of information. So if we call it the nth term, which is just wherever it is in the sequence, we call it a nth term, a sub n. That's what we call it. Okay. Of an arithmetic sequence in which the first term is a sub 1 and the common difference is d, the following formula is what we use for that. So a sub n is equal to a sub 1 plus n minus 1 times d. There's another version of this where we put into terms of a sub 0. And this one is actually related to something you've done in the past. So a sub 0 times n times d. Okay. So what this one looks like is actually if we did y equals b plus mx. So really let me swap that around. Call it dn. dn, okay? Y equals b plus mx. So instead of mx plus b, I just swapped it around. But this is what our linear pattern looks like. We're putting into slightly different terms when we talk about an arithmetic sequence. So instead of the 0th term, which is kind of like a y-intercept, now we're going to use the first term in this case. Okay, either one is really interchangeable. So we're going to go through and just focus on the a sub 1. I'm going to stick with that one throughout, but just know that 0th term kind of refers to like going back one more. So for example, let me talk about that real quick here. So find the 20th term of the arithmetic sequence. This is my a sub 1, a sub 2, a sub 3, a sub 4. As I keep going, blah, 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 what we did before was we just continue the whatever the pattern is and go until we get to a sub 20. That's going to take a while. So instead of doing that, we're going to try to model what's going on here. So key here is figure out our common difference going each time. So in this case, it's plus 7. So d equals 7. A sub 1 is my first term, so that is a 3. If I want to do things in terms of a sub 0, if I go the opposite direction, I would subtract 7. So if I do 3 minus 7, that would give me a negative 4. So that would be my a sub 0 term. It's not actually part of the sequence, but if I wanted to use it as the other potential model, I could. So based on my two pieces of information, a sub n is equal to a sub 1, which is 3, plus n minus 1 times my common difference of 7. That's my formula. Okay. If I do a sub 0, that's going to be negative 4 plus n times 7. Just keep it in the same order. It doesn't really matter which one I use because watch what happens when we find the 20th term, or in this case, it would be a sub 20. Okay, so a sub 20 is equal to 3 plus 20 minus 1 times 7. So that's going to be 3 plus 19 times 7. And if I do that, I got 19 times 7, and plus 3 is going to give me 136. Okay, over here, if I do this one, a sub 20 is equal to negative 4 plus 20 times 7. That is negative 4 plus 20 times 7 is going to be 140. And if I combine those, I still get 136. So again, it just makes a difference if we're calling it a sub 0 right here, or if we're going to put things in terms of a sub 1. Okay, just slight modifications, but it gets the same answer in the end. So talking about our arithmetic sequences, let's talk about, again, finding an equation that represents this sequence right here. Okay, two things we need. A sub 1, which is negative 8. And then what's my common difference? So if I go from negative 8 to negative 6, I'm adding 2. Negative 6 to negative 4, I'm adding 2. So a sub n is equal to my first term, negative 8, plus it'll be n minus 1 times my common difference of 2. And that's it. All right. And again, the main goal of this is I can find out any term I want. So I could jump to any a sub 20, a sub 30, whatever it is. And this is an equation that gets me there much faster than if I try to list all the numbers out. All right, so next thing, write an equation for the nth term of our arithmetic sequence below. So now I have a sub 6, which is equal to 11, and my common difference is negative 11. So again, I need two things to write my formula. I need my a sub 1 and my common difference. I don't have my a sub 1 here, but I do have that n equals 6. And if I go to my formula, I could fill in a lot of information here. So I would do a sub 1 plus n minus 1 times d, right? I actually have n, which is 6, and I have a sub 6. So I can actually replace this and replace my d with a negative 11, and I could solve for a sub 1. Okay, so if I do that, I'm going to have a sub 6, which is 11, equals a sub 1 plus 6 minus 1 times a negative 11. Now we just have to do some little bit of algebra. So 11 is equal to a sub 1 plus this will be 5 times a negative 11. A sub 1 plus a negative 55. So we add 55 to both sides. And I get 66 is equal to a sub 1. So now I have enough to write my equation. I can do a sub n is equal to 66 plus n minus 1 times a negative 11. Okay, so that's my arithmetic sequence equations there. Let's talk about something called an arithmetic means. So find the arithmetic means in the sequence. Basically, what I'm asking for is, can we find the 3 missing pieces that are in this sequence? So think about what's happening here. If I look at my comparison here, what's happening is if I go from here to here, here to here, here to here, and here to here, right? I'm adding 4 common differences. That's what's happening in this case. Okay, so what I have is I have a sub 1, and then this is actually going to be 1, 2, 3. Sorry, this is going to be a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Okay, so what's happening here is we're adding up that many common differences. So a way of kind of representing that is, again, if I use my formula, so a sub n is equal to a sub 1 plus n minus 1 times d. We don't know the d value here. We do know that I'm making, to get to a sub 5, I'm going to take 5 minus 1 is 4. That's what's representing these 4 common differences that are happening here. I have a sub 1 and I have a sub 5 is 45, so let's set that up. 45 is equal to 21 plus 5 minus 1 times d. Okay, so I'm going to subtract the 21 over, and I'll do the 5 minus 1 and give me 4. So I have, let's see here, 24 is equal to 4d. And then I divide by 4 and I get 6 for my common difference. Okay, so to find my missing arithmetic means, I'm just going to take my 6 and add them on to each of the cases. So 21 plus 6 is going to give me 27. 27 plus 6 is 33. And then 33 plus 6 is 39. And just as a quick check, 39 plus 6 gives me 45. Okay, so again, that's how we're using our formula and recognizing what this kind of means here. So this 4D is the fact that I'm taking 21, I'm adding D that many times. That's part of my sequence. Okay, I believe we got one more example we're going to do. Nope, okay, check your progress time. So that's actually it for today. Okay, so again, we're modeling it with our equation, using that equation to find missing pieces and also to extend the pattern further to find any other values there. So feel free, you want to pause it, try this problem out. Pause it, try this one. Pause it for this one. And then last one here. This is a similar scenario. If I say 3 arithmetic means, I mean 13 blank, 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 25. All right, that's it for day 1. Come back for day 2. Take care, everybody.